Hi, welcome to this lecture on soldering. So soldering is where we're joining metals using a filler material of a lower melting point than those of the original metals to be joined together. So basically, if we have two metal things that we want to connect together in a more permanent way, we basically heat them and we use a melted metal in order to connect them. So soft soldering is used when we're dealing with something that has a melting point below 400 degrees, which sounds like a high temperature, but is actually fairly low for metal. And that filler metal that we use is called solder. Now, some metals are easier to solder together than others, for example. So tin, copper, and brass are much easier to solder together than something like steel or aluminum. So the main tool that we use in soldering is called a soldering iron. Now, the soldering iron plugs into the wall and basically just gets hot. And where it gets hot is on the tip. Now, the entire tip gets hot, down from the very end all the way up to about here. And it gets extremely hot. It's very easy to burn yourself or the table or anything else that the soldering iron is going to touch. So you need to be careful when you're using a soldering iron. But that's the portion that gets hot, and that's the portion we're going to use to heat metal in order to solder it. Now, another thing we use when soldering is solder. In this case, this is a spool of solder, and it almost looks like wire, but it melts when you get it close to the soldering iron. And frequently, we'll have a whole set of stuff that we're going to use with soldering. So we'll have our soldering iron. We'll have a soldering iron stand with a sponge, which we'll talk more about in a little bit. Sometimes, so in this case, we have solder in a little tube. You may have a device to hold up a circuit board if you're soldering components onto a circuit board, etc., etc. So there's a lot of variety of things you can use while you're soldering. So solder itself, that little metal that we're going to liquefy and use to join two other metal components, traditionally it's an amalgam, a mixture of tin and lead. And the percentage of how much of those you have defines what we use the solder for. So the more lead that's in it, the lower the melting point is, just as kind of a reference here. So for example, the typical solder that's used for electrical and even mechanical work is 60% tin and 40% lead. But you can get a 50-50 mixture that's 50% tin and 50% lead that's used for plumbing, like joining pipes together. But I want to point out that plumber solder is not suitable for electrical work. So if you're out buying solder, don't get plumbing solder from your local hardware store. Instead, you need to get solder specifically made for electrical work. Now, frequently today, a lot of electronic devices are produced using lead-free solder. And this is for both health and environmental reasons. Lead is toxic to people and animals and the environment. So a lot of electronic devices are made using solder that doesn't have lead in it. It's supposed to be a little bit healthier and better for people and the environment overall. Now, lead-free solder is slightly more difficult to use and is typically done by machines and such, but you can still use it by hand. And it's made of an amalgam of tin, silver, and copper. No lead involved. So another tool that you'll use when soldering is called flux. So flux is a chemical agent, and it's used to remove oxide from metal surfaces. And we need to apply it before or during soldering. So if you're going to solder two pieces of metal together, an important thing to know is that solder itself, the liquid metal, won't bond to those other pieces of metal unless they're clean. And clean means that there's no coating on top of them. Now, a lot of metals react with oxygen in the air to produce an oxide, which is kind of a small, almost invisible coating on the top of the metal of a metal oxide. And solder will not bond to a metal oxide. It only bonds to the metal itself. So if you have metal that's been sitting in the air, then it's going to have a layer of oxide on top of it. And we use flux, which is just a chemical, in order to basically remove that layer of oxide so that the solder can flow onto the metal itself and bond properly. Now, a lot of solder that you buy actually has flux inside of it, and that's really useful because without flux, your solder is not going to bond to metal very well because of all the oxide on the metal. And so frequently the solder you use is called multi-core solder, which means that there's flux inside. So if you think of this as like a perpendicular cut on a piece of solder wire, then you would have solder as the base of the item, but then on the inside you would have 4 or sometimes less little groups of flux running through the middle. So we call it multi-core solder because it has cores of flux inside, which means that as you melt the solder while you're soldering, flux flows out of it to remove any oxide in the way. It produces a kind of a cleaner, easier to do set of soldering. So the basics of how to solder is that first you want to clean the item you're going to solder, and frequently we use flux to do that. Then you're going to tin your soldering iron, which is where you just put a little bit of solder on it. Then you'll heat the item, the two pieces of metal that you want to solder together, and then you'll apply solder to those pieces of metal and hope that it will flow onto the hot metal and join the two pieces. So let's walk through some steps if you were going to practically solder something. So let's say we have a resistor here, and we're going to solder it to a printed circuit board. Now when you have a printed circuit board, you'll have holes in it, which is where you'll push up the item you want to solder. And then on the other side of the holes, you have copper tracks that are part of the printed circuit board. Now what we're trying to do with solder is we're trying to join the leg on the resistor to the copper tracks on the board, because the current's going to flow through copper tracks on the board to the different components. So we're ultimately trying to join those two things. So the first step is to push your component up through. Sometimes because you're doing this upside down, your resistor will fall out, so sometimes you'll just bend a wire over. Now you're going to bend over the wire that you aren't soldering immediately, because you always want to solder with the wire straight and sticking up. So we'll bend one over just to kind of hold the resistor in place. Next step is to clean our iron. So we want to take away any dirt on the iron, because soldering irons get surprisingly dirty and almost charred. And we'll use a damp sponge for that. So on a soldering iron stand, there's frequently a little sponge, and you just wipe your soldering iron carefully on that damp sponge, and that'll clean off any dirt or residue that's accrued on there. Never wipe your soldering iron on a dry sponge, because if the sponge is dry, then when you put on the hot iron, you will, instead of cleaning the iron, you will burn off small parts of the sponge onto the iron and make it even more dirty. So if you're working with a soldering iron and the stand has a little sponge on it, if the sponge is dry, don't use it. Add a little bit of water to wet it so that then you can actually clean the iron. If your iron is clean, this will help your solder to flow properly. So next step is to tin the iron. And this means you just put a little bit of solder onto the end of it. This is going to help heat flow in the next step. And then in step 5, we apply heat. And this is the step that usually people make the most mistakes in. And so I'll give you a few tips here. First, the soldering iron is typically a pointed end. You don't use the very tip of the soldering iron to heat. You're trying to use the edge, because you want to get as much heat contact between the iron and the components as possible. So the edge is longer, and so it will give more heat when you apply the edge to the items. And the other important thing here is that what you're trying to heat is not solder. You're trying to heat the two pieces of metal that you want to join together, because solder ultimately flows toward heat. So if I want my copper track and my resistor wire to be soldered together, I need to get them both very hot. So I use the soldering iron, and I'll push it against both the copper tracks and the wire on the resistor to heat them both. After I've heated both of those things, usually for about 3 seconds, then I'll bring the solder down to that heated joint. Now I'm going to touch the solder to the heated metal on the copper and the wire. I'm not going to touch it to the iron, because solder flows toward heat. If I touch it to the iron, well then the iron's going to be the hottest thing there, and the solder's simply going to flow up and bunch up on the iron itself. It's not going to actually flow onto the copper track and the wire that I'm trying to actually join. So instead, I'll put the iron on one side, heating the copper track and the wire, and then I'll bring the solder into the other side of the joint so that the solder will melt and flow across the joint towards the iron, which will create a good blob of solder that will actually bond the two items together. Now, it's important that you do this quickly. There's almost an art to it when you do soldering, because if you hold your iron on too long, then you might accidentally burn the copper track. But if you don't hold it on long enough, then it won't be hot enough to melt the solder. So you learn to do it as you practice. Now, after you get a good, nice looking blob of solder that's melted and is bonding your two items together, you pull both the iron and the solder away together. So you don't just pull one or the other. If you pull away the iron, I see students do this, they go, oh good, I'm done, and they pull away the iron, but they leave the solder there. then what ends up happening is your stick of solder that you're using is stuck to your board because it's still attached. So then you have to reheat and remelt. So you just pull both away, and then you look at the joint to make sure it looks okay. So let's talk about some good and bad solder attempts and what your soldering joint may look like. So a good joint has a very smooth look to it and is obviously attached to both the item you're trying to solder, or to both items you're trying to solder. So in this case, this is a good joint because it's attached to the copper and to the wire that's sticking up from the resistor. Now a bad joint, so in this case, let's say that the person heated the copper track, but they didn't heat the wire very well, and they didn't use enough solder. So you might have solder that flowed onto the copper track, but it didn't flow into the wire on the resistor, and so there's actually no real connection there. Another example of a bad joint would be the opposite, is that I heated the wire, but I didn't heat the copper track properly. So when I added the solder, it flowed onto the wire, but didn't flow onto the copper track. Another bad attempt, even though the solder joint looks good, if I heated it too long, then I may have burned my track. And if my track is burned, then it has all of this oxide and residue on it, and no current can pass through that. So that you end up with no real electrical joint, and you can't get any current to flow. So something you can tell when you look at a soldering joint, you can kind of begin to tell if it's good based on how its appearance. So in this case, if you look here, I kind of have a chunk of solder, but it's real jagged. So if I look at it, when I analyze the board, it kind of looks like a jagged lump instead of a more smooth bump. And in that case, that means that there was probably too much solder, or the heat wasn't applied properly, or something like that. And I may want to smooth that out. Or sometimes if I do my soldering and I look and I can tell that it just doesn't look like there's enough solder. It may be kind of smooth, but like the wire that I soldered is clearly visible throughout the entire joint. There might just be not enough solder, and I would need to add more. So a good joint is one that is fairly smooth. It's not jagged like the upper one, and the wire is totally encompassed around the joint with the solder, and it'll just look nice. You'll get more experience with this as you do it. So let's talk about soldering safety. First, you always want to use a soldering iron stand, something to hold the iron in when you're not using it, in order to prevent accidental contact with the hot bit of the iron when it's not in use. Never just set your iron down on the table, because inevitably someone's going to bump into it and burn themselves, or it's going to be bumped into and it's going to tilt down and burn the table. Please don't do that. You need to watch loose clothing. So when you're digging into your device and you're doing lots of soldering, if you have long sleeves or things that hang down, those things can actually get a little bit too close and they'll burn. So just be careful of that. It can be useful to bring some pins or something to kind of pin up your sleeves if they're very loose sleeves, to keep them up above what you're working on. And when you can, it's good to use eye protection when soldering, because that'll prevent solder or boiling flux from splashing into your eyes or things like that. So again, whenever you're dealing with something hot or chemicals, it's always good to use eye protection. And this is a really important tip: don't breathe the fumes. So the chemicals used in flux and the lead used in solder are not friendly to people. So it's really not a good idea to breathe the fumes when you're burning them with a soldering iron. So what I recommend is that you not sit there and breathe deeply on the fumes. When you can, you should always solder in a well-ventilated area and kind of do your soldering, step back a little bit to let things dissipate, and just be very cautious about that. Okay, so let's review. Soldering is using a metal with a low melting point to join two other pieces of metal. We use soldering to connect components together on a circuit board, or more properly, to connect the components to the circuit board itself. Solder flows towards clean, heated metal. It doesn't flow towards cold metal or towards dirty metal or metal with oxide on it or things like that. We want clean, heated metal. And with soldering, practice makes perfect. So the first time you solder, it's not going to work very well, but as you get more practice, you'll begin to get the feel of it, you'll begin to see what good solder joints look like, and you'll become better at it. Thanks.